Welcome everybody to lesson 4 of the MATH2 module. This lesson we're going to talk about planes and linear algebra part, and we will continue with finite state automaton in the languages part. So let's first look at what we've done last lesson. If we see a line in 2 dimensions, then we can represent it in two ways. We can have a linear equations or we can have a vector form. Let's start with the linear equation. If we want to look at what line this linear equation represents, we just have to find two simple points on this line. So let's make a small x and y. Then we have 2 points. So for instance, let's pick x being 0, then 4y would be 12. So that means y would be 3. So we know the point 0, 3 is on the line. So 0, 3, that would be about here. Let's pick another point. So let's say y is 0. Then we would have 3x being 12. So that would mean x is 4. So now the point 4, 0 is also on the line. That's about here. So the line which is represented by this equation would be this line. Okay, so with the help of a linear equation, we just find two simple points and then draw a line straight to these simple points. We can do the same thing, try to find a line with the help of a vector form. So again, let's first make a small drawing of an x and a y-axis. And then again, we have to find 2 points on the line. And of course, with a vector form, one of the points is already given. And that's the starting point, 4.0. So 4.0 means we have this point on the line. And then any other point can be found by using lambda with a specific value multiplied with minus 4,3. So let's choose lambda being 1. Then the second point we can find is 4.0 plus 1 times minus 4,3. So that would give us the 0, 3. Okay, so 0, 3 would give us this point. And again, we have a nice line going to the points. So whether you use the equation or the vector form, finding the line itself is just easy by finding two different points on this line. In a 3D space, we can also talk about planes. And if we talk about planes, of course, we need three variables, an x, a y, and a z to represent a plane. So for instance, we can have an equation with those three variables. So for example, 3x plus 4y minus 2z becomes 5. If we look at this plane, we can figure out some points on the plane. For instance, if we would choose x being 1 and y being 0, then that would result in z being minus 1. Because now we have 3 times 1 plus 4 times 0 minus 2 times minus 1 being 3 plus 0 plus 2 being 5. So this is a good point on the plane. Another simple point would be the point 1, 1, 1. Because then we have 3 times 1 plus 4 times 1 minus 2 times 1 would be 3 plus 4 minus 2, and again that would give us 5. So these are two possible points on this plane. Another way to describe a plane would be with the help of a vector form. So a vector form in a 3D space, again we need an x, a y and a z. we need to have a starting point, which would be a three-dimensional point, and then we would have two direction vectors. So we have a starting point, one direction vector, and another direction vector. So if we look at possible points on this plane with the help of a vector form, then we'll just choose values for alpha and beta. Simplest one is choose alpha being 0 and beta being 0. And then we have the point 1, 1, 1. Okay, another simple one would be choose alpha being 1, beta being 0. And then we would have the point 1 plus 2 would be 3. 1 minus 2 would be minus 1. And 1 minus 1 would be 0. So again, possibilities for this plane. If we check, by the way, the second point, then you would see that in the equation it would give us 3 times 3 minus 1 times y plus 2 times 1 times 4. Huh? Sorry. So this would give us 3 times 3 plus 4 times minus 1 minus 2 times 0. So that would give us 9 minus 4 would be 5. So indeed, both points are on the plane, whether we look at the equation or whether we look at the vector form. Of course, if we look at it in a vector form, we need to have two vectors to show the directions, but they have to have different directions. Because if I have a point and I have one vector in this direction, and I have another vector which indicates exactly the same direction, then together they wouldn't make a plane, but they would make a line. So the two vectors we choose have to be different. For instance, these two. And different directions means they are independent. So two different vectors with different directions are called independent. With the same direction, they are depending on each other. And then one is a multiple of the other. So the example I gave you, we had this vector. And that one, you can straightforward see that this vector is twice that vector. Remember that we don't need to look at the starting position, because a vector can start anywhere in space. So let's look at these two vectors. Are these depending or not? So do they give the same direction? So 2 minus 4, 3, is that the same direction as minus 1, 2, 1.5? So to check this out, we have to see if we can find a lambda in such a way that 2 minus 4, 3 would be lambda times minus 1, 2, 1.5. Okay, if we look at the first one, to have 2 become equal to lambda times minus 1, we would have to choose lambda being minus 2. So 2 would be minus 2 times minus 1. Minus 4 would then also be minus 2 times 2 would be minus 2. So this would check. But 3 is not minus 2 times 1.5. If I take minus 2 times 1.5, that would give us minus 3. So that doesn't fit. So the two factors are not depending. They are independent. So we could use them to represent a plane. Okay, so how can we find the vector form if we have a plane given with a specific equation? So we have this equation, x plus y plus z equals 3. How can we find the corresponding vector form? Okay, basically it's the same way we would find a vector form in a two-dimensional space. The only thing now is that we need 3 points instead of 2. So let's start with the first point. So let's find a point on this plane. Well, an obvious one would be 1, 1, 1. And so 1 plus 1 plus 1 equals 3 is nicely on this plane. Let's pick another one. Okay, if we choose x being 3, then we could make the other two 0. And that one is on the plane as well. Okay, then we need a third point. So let's say we pick x being 1, y being 0, then we still need 2 for z to have this one on the plane. 1 plus 0 plus 2 equals 3. So now we have 3 different points. And to get a vector form, we just write it down with one of the points as a starting point plus 2 direction vectors. So how can we find those 2 direction vectors? So the 2 direction vectors could be found by just finding a movement from one point to the other. So okay, let's look at a movement from A to B. So how can we get from A to B? Then in the x direction we need to go up 2. And to go from 1 to 3, we need to go in the x direction plus 2. In the y direction we should go down 1, and in the z direction we should go down 1. So the direction vector to go from A to B is 2 minus 1 minus 1. Okay, let's find another direction vector. For instance, AC. So AC would be go from 1 to 1 would give us 0. From 1 to 0 would give us minus 1. And from 1 to 2 would give us 1. The only thing we need to check now if these 2 direction vectors indeed are different ones. So are they independent? And of course you can see that at once because 2 can never be depending on 0. I cannot find a lambda in such a way that 2 would be lambda times 0. So okay, these work perfectly. So a vector form would be 1, 1, 1 plus lambda times 2 minus 1 plus mu times 0 minus 1, 1.